Tonight, at some point, you're probably going to plug your phone into a charger, maybe before bed, maybe when you notice it's at 12% and starting to make you slightly nervous. You plug it in, and instantly, it starts charging. It feels simple, almost effortless. But that electricity didn't just appear in your wall. It may have started its journey miles away, in a field of giant wind turbines slowly spinning in the air. And between that spinning turbine and your phone charger is one of the most complex infrastructure systems in the modern world. So how does electricity actually make that journey? Let's start at the very beginning, where the energy is created. Wind turbines are designed to convert motion into electricity. When the wind blows, it turns the turbine's blades. Those blades are connected to a shaft inside the turbine, and as that shaft spins, it drives a generator. Inside the generator, something interesting happens. Magnets and coils of wire interact in a way that produces electricity. As the shaft spins, it creates a flow of electrical current. That's the moment electricity is born. But the electricity produced at the turbine isn't ready to power your home just yet. At this stage, it's generated at a relatively low voltage. And that's a problem, because sending electricity long distances at low voltage is inefficient. A lot of energy would be lost as heat along the way. So the first thing that happens is the electricity is sent through a transformer. This transformer increases, or steps up, the voltage to a much higher level. Think of it like putting electricity into long-distance travel mode. At higher voltages, electricity can travel much farther with much less loss. From there, the electricity enters the transmission network. This is the part of the system you've probably seen before. Those tall metal towers carrying power lines across open land, highways, and even mountains. These lines carry electricity over long distances, often from remote wind farms to cities where the energy is actually needed. And the scale here is huge. Electricity might travel hundreds of miles, sometimes even across entire regions, before it reaches the place where it will finally be used. Now here's something that makes electricity different from almost anything else we use. It can't really be stored easily, at least not in large amounts. That means electricity has to be generated and used almost at the same time. So as that electricity is moving through the grid, there are operators constantly watching and adjusting the system. Their job is to keep everything balanced, because if too much electricity is generated, it can overload the system. If too little is generated, parts of the grid can lose power. So behind the scenes, there are control centers tracking demand in real time. Every time someone turns on a light, charges a phone, or starts a washing machine, the system has to adjust. It's like a giant balancing act happening constantly. As electricity moves closer to cities, it reaches another key part of the system, substations. Substations are where the electricity is redirected and adjusted. They take the high voltage electricity coming from transmission lines and reduce it to lower voltages that are safer and more practical for local use. You can think of substations as major intersections in the electrical network. They don't just pass electricity along, they manage where it goes. From substations, electricity enters the distribution network. This is the network of smaller power lines you see along streets and neighborhoods. These lines carry electricity much shorter distances, delivering it to homes, businesses, and buildings. Before electricity enters your home, it passes through one more transformer. You've probably seen these without thinking about them. They're often mounted on poles or inside those green boxes on the ground in neighborhoods. This final transformer reduces the voltage again to a level that your home can safely use. Now the electricity is ready. It enters your home through your electrical panel and flows through the wiring in your walls. From there, it moves to outlets, lights, and devices. And finally, it reaches your phone charger. All of that happens in a fraction of a second, from a spinning turbine in the wind to a small device in your hand. But the system doesn't stop once the electricity reaches you, because the moment you unplug your phone or someone else turns on an appliance, the entire system adjusts again. It's constantly responding to changes. And this is where things get even more interesting, because wind energy isn't perfectly consistent. The wind doesn't always blow at the same speed. Sometimes it's strong, sometimes it's barely moving. So the amount of electricity being generated is always changing. That means the grid has to be flexible. To handle this, engineers are building new technologies into the system. One of the most important is energy storage. Large battery systems can store extra electricity when production is high and release it later when demand increases. This helps smooth out the fluctuations from renewable energy sources like wind and solar. Another innovation is the smart grid. Smart grid systems use sensors and real-time data to automatically adjust how electricity flows through the network. Instead of relying entirely on manual control, the system can react almost instantly to changes in supply and demand. This makes the grid more efficient and more resilient. Because at the end of the day, reliability is everything. When you plug in your phone, you expect it to work. You don't think about turbines, transformers, substations, or control centers. You just expect power to be there. And most of the time it is, because this entire system is designed to be invisible. It works quietly in the background, moving energy across vast distances, balancing supply and demand, and adapting to constant changes. And the scale of it is incredible. Thousands of turbines, thousands of miles of power lines, hundreds of substations, all working together to deliver electricity exactly where it's needed. It's one of the most impressive infrastructure systems ever built, and like many of the systems we explore on this channel, most of it goes completely unnoticed, until of course it stops working, which is when people suddenly realize just how much depends on it. So the next time you plug in your phone, it might be worth thinking about where that electricity came from, because there's a good chance it started somewhere far away, carried by the wind, and traveled through a network of infrastructure designed to power modern life. And somehow, it made it all the way to your charger. Also, let's be honest, your phone is probably going to need charging again in a few hours anyway. If you enjoyed this video, make sure to like and subscribe to Hidden Infrastructure of the World. Also, comment down below what hidden infrastructure you want to see next. See you in the next video.